Hi everyone. There's one fundamental consequence of this idea of a de Broglie wave associated with every single particle, and that's this idea of quantum tunneling. And I wanted to set this aside and really talk about this quite a bit because it explains a lot of things that we will talk about going forward. And the basic idea is given by this diagram here. So what this represents, it's basically an energy diagram. And so you're supposed to imagine, there's this flat area, but in the middle, there's this spike, this potential energy spike that occurs. And so, imagine it to be, a little bit of a barrier, right? So classically, what we would do is we'd say, okay, what's the energy of the particle? What's the kinetic energy of the particle that I'm dealing with? That's the dotted line, okay? Now, because the dotted line is less than the total potential energy here, if I imagine a particle moving, with a certain speed, 1/2 mv squared is going to give me the kinetic energy, that's this interval, it's going to hit this potential energy, and because the kinetic energy is less than the potential energy, it cannot go to the right. It can't make it past this, because in order to get past, it's got to go inside. Inside here, effectively, the potential energy is larger than the total energy, which cannot be because the kinetic energy would be negative, which is impossible. So physically what happens is a particle would reach that barrier and bounce. And so that's what happens classically. The particle does not go past the barrier. Now, if we switch the story and talk about waves, and this is truly wave phenomena. We're not really quantum mechanical yet. If we could be talking about a water wave, for example, and imagine this is the ocean bed floor, for example. We've got a water wave coming, and the potential energy spikes. Well, what happens is that, or maybe it's better to think about light. We've got a light beam coming in here. We've got a nearly opaque object here. Some of that light wave bleeds through which classically would be impossible if this were a particle. But for waves do have the ability to propagate through this intermediate space. And so what happens is that basically you have an incident wave. Some of it refracts through, and some of it will reflect back. And so what you have is net energy flow to the right. A little bit of that energy flow bleeds through. This is called refraction in optics. And most of it reflects back. That is what happens at a quantum mechanical level if this potential barrier, the distance here, the width, is comparable to the de Broglie wavelength of the particle. So here we're talking about a distance that's very small, for an electron. However, this is fundamental in both technology. So here we talk about a scan tunneling, a tunneling microscope. And what happens is basically this tip here is very close to your substrate, your sample. And as it drags across, it never touches, but as it drags across, a certain amount of the electron wave bleeds across the empty space and actually produces a measurable current. And as you drag this across, if there's fluctuations in the height, you'll get fluctuations in the current. And it's very sensitive to that. It's actually an exponential dependence here. So you have a very sensitive measurement of height. And that's how you can get pictures like this, where you're actually getting a picture of individual atoms. And that's because you can drag it across with this tunneling microscope. And it's using this phenomenon as a means of technology. Also, this tunneling is one way to understand why or how radioactivity works. So we've got a barrier, the nucleus, is holding on to its component parts. There's a potential energy associated with them locked together. But it's very small, and so occasionally enough of the energy of one of the protons or neutrons bleeds past where classically it shouldn't be able to get out. But it bleeds out, and all of a sudden there's a particle on the other side. And that particle then gets spit out, and all the energy that it had, because it was trapped inside, gets released as kinetic energy and blasts out as radioactivity.